In this video, I'm going to do a very brief introduction to rational functions, how to multiply and divide rational expressions. So let's first start by defining what are rational expressions. So a rational expression is simply the quotient of two polynomials. Let me give you an example of what I mean. So let's say I have x squared, look like an x squared minus 1 over x squared plus 2x plus 1. This is a rational function. I have a polynomial over a polynomial. I could have something else like, let's say, x over 3x squared plus 4. That is a rational expression. So we're simply taking two polynomials and dividing them. Now, there are different applications, but what we're going to focus simply on is the algebra behind it. We're going to look at simplifying them. So one thing we need to know before we get too deep is that rational expressions are simplified when the only common factor of the numerator and the denominator is 1. So what I mean by that is that if I can factor these and cancel out common factors, then that means it isn't simplified. So it's simplified when I can either no longer factor and they don't have common ones on the top. So for example, let's say I had x plus 1, we'll just leave it factored, times x plus 2 over x plus 3 times x minus 4. So this, sorry, not 3. Let's make that a 1. So when I'm looking at this particular one, it is not simplified because I have these x plus 1. So in order to simplify this, we would divide those out, and this simplifies to be x plus 2 over x minus 4. So that makes this simplified. The only thing that can go into them now is a 1. So the name of the game for rational expressions is factoring. Before you start getting into it, it's a good idea to start factoring. So let's jump into simplifying, and I'll show you how it's done. So here I have an expression. I have a rational expression. It's a polynomial over a polynomial. And what we're going to do is we're going to simplify it. So to do that, we're going to factor the numerator. We're going to factor the denominator. Now, if you forget how to factor, there are videos on this channel of how to do that. There are tons of resources for factoring, so I'm not going to go over that in detail. So the first thing I'm going to do is I'm going to factor the numerator and the denominator. Since I'm simplifying, I'm looking for what's in common. So let's see what we got. So the top is going to factor to be, let's see, so that would be x minus 6 times x plus 1 over the bottom. You could be thinking, well, this doesn't factor. Actually, it does. This is difference of squares. X squared is a perfect square, and 1 is a perfect square. So since I have difference of squares, this factors to be x minus 1 times x plus 1. And voila, we see here that they both have a common factor of x plus 1, so we cancel it out, and this simplifies to be x minus 6 over x minus 1. Now, one of the biggest mistakes I see all the time, this is all the time, don't do this, is people will say, oh, there's an x, I'm just going to cross those out. No, that is not just wrong, that is very wrong. No. X is with the term minus 6. So it's x minus 6 over x minus 1. Think of these as quantities. We're not just going to take this out of the middle of the quantity. That's not how this works. So they have to be factors to cancel out. Okay, since these are being subtracted, it's all one big thing. Okay, so please do not do that. That is very, very wrong. I cry a little bit on the inside when I see that. Let's try again. So here I've got x squared plus 6x plus 5 over x squared minus 25. Why don't you go ahead and take a second, pause this video, and see what you come up with. I'll go over it in a minute. All right, so let's go ahead and get to it. So the top here is going to factor to be x plus 1 times x plus 5. Hopefully you got that one, didn't use 2 and 3. And the bottom, difference of squares, x minus 5 times x plus 5, and we see there's a common factor of x plus 5. So we cancel those out. It simplifies to be x plus 1 over x minus 5. So that's how we simplify. We factor, we cancel out the like terms, nothing too bad. Now, the other easy ones to do are multiplication and division. Now, you could be looking at this thinking, oh my goodness, you just made this crazy difficult. Not really. So when we multiply, think back to multiplying with fractions. Let's say I had 1/2 times, oh, let's call this 2/3. So when we multiplied here, with fractions, we would multiply straight across. Remember, we do 1 times 2, 3, something that simple. But if you notice in the example I gave you with the 2's, they both have a common factor. See here, I have a 2 on the top, 2 on the bottom. So those would divide out, leaving a 1. And so to simplify this, before I even multiply, 1 times 1 is 1 over 1 times 3 is 3. So I can simplify it before I multiply straight across, and that's what I'm going to do with rational functions. If I factor and I see, oh, there are common terms, then that is going to make my life easier. So let's start by factoring. I'm going to deal with the right one first. So I'm going to draw my big division bar. Now 3x is just 3x. It is what it is. So let's see. So I'm going to have 3x. I'm going to have an x. And so this is going to be 3x minus 1 times 3x, or sorry, x minus 1. So as I multiply out. And then over here, let's factor these. So here I've got, let's see, that'd be 3x plus 1 times x minus 1. Again, if you're having trouble with factoring, there are tons of videos out there with how to do that, so go take a look. This top one here looks like a doozy because I have this x cubed, and well, factoring is a little bit tougher. But I see that these have a common factor of 3x. Notice that 3 goes into 27 and 3, and they both have an x. So I'm going to take out a 3x. I'm just going to do this on the side just to save a little bit of room. That'll be 1 minus 9x squared. Now you still could be thinking, oh my goodness, this looks crazy tough. Well, this is difference of squares. 1's a perfect square, 9x squared is a perfect square. So this whole thing factors to be 3x, parentheses, 1 minus 3x times 1 plus 3x. And I'm good to go. Now from here, we're looking for common factors. So let's look at what we have in the numerator denominator. Let me change some colors here. So I see here that these 3x's are in common, so I'm going to divide those out. Those are left as 1's. Let's see, I've got, x minus 1, those divide out to be 1. And I also see right here, I've got a 3x plus 1 and a 1 plus 3x. Those are actually the same thing. Those divide out to be 1's. So when I do all of this simplifying, if you notice, what do I have left? Well, the bottom is a 1, because everything divided out here to be a 1. And on the top, I'm left with 1 minus 3x times 3x minus 1. Now, just as a rule of thumb, if you're working in my class, I don't really care if you multiply this back. I'm perfectly fine if you leave it like this, because then we can find the zeros a lot easier. We can do all kinds of stuff. But technically, this one you can actually do a little bit more with. Now, if you got this answer, you're doing great. But watch what happens when I take out a negative 1. I'm going to take out a negative 1 in the first set. And look what happens. Both of these signs flip. This becomes a minus 1. This becomes a plus 3x. And it becomes the same as the other factor I have here. So I can rewrite this as negative 1 times 3x minus 1 squared. If you want to get real fancy, you could write it like this, or if you wanted to leave it like the version I have up here, you can do that as well. So multiplying is very similar to just simplifying. You're factoring, you're finding what there is, simplifying, and then just multiplying it out. You don't need to multiply out these factors. It makes it a little bit tougher to find the zeros. Now, let's go to dividing. Now, before I get to an example with a rational function, let's review with just plain fractions. So with just plain fractions, if you remember, to divide, what you would have to do is you would have to multiply by the reciprocal, meaning the flip version of the second fraction. So I'm going to multiply by 5/4. And then we would proceed with the operations as normal, multiply across. But I notice here that in my fractions, I have a common factor of 2. So I divide by 2 here, negative 1 here. So I'm just simplifying that a little bit before I get into it. Just makes things easier. Then we multiply across. 1 times 5 would be 5. 3 times 2 would be 6. So we're going to take that same idea of multiplying by the reciprocal to rational functions. So let's get into it. So before I go ahead and do all of my factoring, I'm going to multiply by the reciprocal, and I'm going to put that over here just so that way I save a little bit of space. So 2x minus 8 all over x squared minus 9 times the reciprocal of the second. So we are flipping the second fraction, multiplying by the reciprocal. Then we go ahead and do our factoring. Let's change to green just because we can. So let's see, the one on the left here factors to be x minus 4 times x plus 2. And again, here we have difference of squares. Hopefully you've picked up that those are common. They're going to come up a lot in this class. Times x plus 3 or x minus 4. So let's see what common factors we have that we can cancel out. So I see here I have this x plus 3. Those cancel. And I see this x minus 4. So I'm left with x plus 2 over x minus 3. So that's the end of our very brief tutorial on how to simplify rational functions, how to multiply and divide. Remember, the name of the game is to factor. Best of luck.